Everyone, welcome back to our channel that is Chemical Engineering. Myself Dr. Kirti Zare. Today I am going to introduce you about the Picard successive approximate method which is useful into the solving ordinary form of the equations. There are the different type of the application of this method. Definitely this is the one of the very effective mathematical tool to solve the problem related with the process control, controlling the devices, population dynamic model, electric field, physics field. It is also used into the heat transfer, mass transfer, transport phenomena, which is the generally in the combination of fluid mechanics, heat transfer and the mass transfer subjects. It is also utilized into the reaction engineering. It is used into the process modeling and also simulate the any particularly problems, right? So let us start for this particular type of the problems like the Euler's method, modified Euler's method, Runge-Kutta methods. This is the method, this Picard successful method is also utilized for the differential form of the equations. So they are giving the problem statement that dy by dx is equal to the x minus y, where x is equal to the 0.2. You are supposed to find out what should be the value of a y when y is equal to 1 and x is equal to the 0 by using the Picard successive approximations method, right? So they have mentioned the limits x as the 0.2, right? Next value of x is equal to the 0 and y1 is equal to the 1, and you are supposed to find out the what should be the value of this. So generally this different method are the trial or you have to perform the iterations over there, but the some of the times the student having the question that how much iteration is going to involving over there or how can you calculate it. So generally it is with respect to that how much or which values they are going to ask, up to that you are supposed to do the iteration. In the sum of the numericals they are also mentioned that you have to perform the 2, 3 or the 4 iteration, or else you are supposed to go for the accuracy level. And the fourth point is that you are of the answers. Alright, means definitely this is the iterations and the trial and error method. So you have to perform and check that at which point will be getting the higher efficiency through this particularly form of the methods. So let us start for this. So it having the Picard successive methods, you are supposed to calculate the y1 accordingly the y0, which is the integration of x0 xn, which is the function of x y 0 into the dx, right? So you having the y0 initially value become the 1 plus xn, extreme value or upper value is 0.2, x value become the 0, which is the function of x and y0. So x minus the y. So you have to consider the this function over here and you have to do the iteration of this, right? So 1 plus, again you have to put the value of a y over here, that become the 1 into the dx. If you are going to simply do the iteration of simply if you are going to do the simply integration of this, so it become the x square by the 2 and minus the x, right? Minus the x, and again you having the limit 0 to the 0.2. So now we are supposed to put this particularly limit over the here. That means that you have put up the value of x over here, that is 0.2 square by the 2 minus the 0.2 minus, again you have to supposed to put this limit, that is 0 square by 2 minus the 0, but this whole term become the 0. So if you are going to solve this particularly term, right, 0.2 square by 2 minus 0.2 plus through the calculator. So you are getting the value become the 0.82, right? So you are getting the value become the 0.82. That is the first value. So this is the first approximation. Now you have to perform the second approximation, right? So just go for the second approximation by the same manner, right? So for the calculation of this, now we are supposed to calculate the y2 is equal to the y0, which is the again x0, upper limit is xn, which is the function of the x into the y1 into the dx. Because the initial stage you are supposed to consider the y0, that is the first value, that is the initial value. But now you are already find out the value of the y1, so you are supposed to consider the y1 over here, right? So just put the value of this. So y0 become the same value, that is the 1. Again they are already specify the limit, that is the 0 and 0.2, which is the again the function of the this, that is the x minus the y, right? So x minus the, now you are already calculate the y1 value, that become the 0.82. So you are supposed to consider this value into the dx, right? So same manner you have to perform the integrations over here, that is the y2 value become the 1 plus again the same manner x square minus x square by the 2 minus 0.82 into the x, and you are supposed to put the limit over here, right? So similarly manner, now you are getting the value of y2 here, that is the 1 plus 0.2 square by the 2 minus 0.82 multiplied by the 0.2 minus again 0 square by the 2 minus 0.82 multiplied by the 0, right? So if again this total term become the 0, and if you are going to solving this by using the calculator, so you are getting the y2 value become the 0.85, right? So you are getting this value become the 0.85. Now again, now because first value become the 0.82 and second value become the 0.85. So again you are perform for the third approximation. If you are getting the nearby values or up to the 0.85 value, so you are going to stop the iterations over there, right? Now just go for the third approximation by the same manner, right? So again you are supposed to calculate the y3 over there, that is nothing but the y0, which is the again integration of x0 to the xn, which is the function of the x, and now you are supposed to consider the y2 over there into the dx, right? So y0 value become again the 1, which is already given, xn become the 0.2 and x0 value become the 0. Again this value means again you are supposed to consider the same function, that is the x minus, you are already performed this value, that is 0.85 into the dx. Now you are again do the integrations of this, so you are getting the value become the 1 plus the x square by the 2 minus 0.85 multiplied by the x 0.2 and the 0. So you are supposed to put the limit over here, right? So that value become again 1 plus x square means again 0.2 square by 2 minus 0.85 multiplied by the 0.2 minus again 0 square by the 2 minus 0.85 by the 0. So this bracket is again the 0, right? To become the 0.85, right? So this is the value of a y3, right? So if you are going to compare the y2 and the y3, so you are getting the same value over here, so you can stop the approximations over here. But sometimes if in the numerical statement, they have mentioned that you have to perform the 4 or the 5 or the 6 iteration. So accordingly you have to perform it, right? Thus particularly numericals through the Picard successive approximations method, which is generally utilized into the ordinary differential form of the equations, right? So please like, subscribe, share my channel, and if you're having any doubts, so you can also write into the comment box. Thank you so much for watching.